Take two, because no one can parallel park without hitting their bleeper button on their car 50 times. If you hit the button to make sure your car is locked 10 or 12 times, you're being a dum-dum. Factory bullets don't foul the bore with lead. Cheap DIY cast lead bullets will foul a barrel, maybe even gas tubes. Jacketing them requires swaging dies or plating gear if you want to electroplate your bullets. On an industrial scale, it's cheap and is almost the same way, in fact, it's exactly the same way, the cartridge brass is made for most bullets these days. Because the robots can do this and it doesn't require a bunch of heat. The process is illustrated, but if you want to look it up, you can watch the process for it. But let's try this idea, since I mentioned the cartridge brass. DIY versions can also be swagged or electroplated, but for small runs it's much more expensive. But it can be made from common materials: copper tubing, copper strip, brass. Used brass, 22 caliber rimfire shells can be, heated up and annealed, or not even done that, and reshaped into the ass ends of actual projectiles. And then inside of this you place a copper wire or stick, a lead one, and then run it through the same sizing die, just a little bit more hardcore version, to resize the bullet to be an ideal shape, and then trim it. What's next? Full metal jacket castings, where you cast your brass or copper? Yeah, you can. They also make entire machines to do this. They're just miniature versions of the ones that are used at the factory. You can also do this method, if you want to learn how, to make every part of the bullet except for the propellant. Yes, you can actually make primer pockets and primers and anvils. All of these processes are available through patent data if you want to look it up. But we're talking about the most common method for making a bullet, and one of the oldest. Again, heat was used for making shot, if you're not aware of this, by dropping liquid lead through the air over a distance, allowing it to form mostly a round shape under surface tension, and having it cool off in water, and then maybe running it through a mill that would capture the individual bits and press them into correct shape. Another method would be to bang the pieces of metal into the shape you wanted for the pellets. And of course, because that is the basis for bullets, and part of the reason for ball ammo being called ball ammo, even though that's not really the name it should be used, honestly. That's another video I've already done. The next step was, well, can we make it swag or swagged, where you take a chunk of lead, because it's soft, and just mash it into the right shape and not melt it in the first place. And you end up with hard or soft lead based on the metals in it, and also by work hardening you might end up with that sort of thing as well in this process. DIY versions can be electroplated or swagged the same way that the factory produced stuff is. But you can get away with this only if you are willing to spend the money on it, hypothetically. And this can again be done from 22 caliber casings, copper tubing, metal strip. Copper tubing is the method I did when I was younger. I used nails, but you can use a tungsten pellet, it's called, but it's actually a metal rod, and a piece of copper that's slightly longer than that, and on both ends, crimp one end down to be a blunt end, the other end be a point. There you go. We use nails. Literally just forming it around a nail worked really well. And that was for making BB gun slugs, because I wanted to be able to do that. We had rifled barrels. I didn't know what they were from, but apparently they were from air guns that were rifled, so we used them. But this all costs more for the run. Greased lubing on a lead bullet will reduce the barrel getting lead in it and fouling. And adding a copper or aluminum gas check at the base, which is a disc or a cup placed on it, may not leave any lead or copper behind at all. And the idea with this is really simple. The copper piece in the back acts as the gas check for the pressure, engages the rifling directly, and has a habit of wiping the rifling and lands and grooves clean by just being basically a bore cleaning kit mounted on the bullet, sort of like the brass casing would be. But the process for making them is the first step for making a full metal jacket. It's almost identical. It's just a modified version that uses less metal. What's this grease lubing thing anyway? Let's not think any strange thing here. A tumble lube grease mix is used. This is a mixture of 50-50 in the case of Lee liquid alox and Johnson's paste wax. I'm trying to get the names right. Basically, it's wax and a lube mixed together, and when you put them in hot, or warm anyway, they cool on the surface of the thing and lube it. And you can also crimp on a copper cap on the bottom of your lead bullet, and it'll actually work that way. You can also integrate it in the process of making the bullet in the first place and mash it in, or even mold it in, but usually it's just pressed on. A 45-45-10 mix, if you've seen it, is Lee liquid alox, Johnson's paste wax, and then at 45-45 ratio, and then 10% mineral spirits. The bullets are just rolled in it and then allowed to cool with the material on it, and it sticks to them. It has a habit of igniting and burning off in the barrel. What to do, wackadoo, that would be cheap, like tumbling with whatever fluff you want to put on it to make it work better. That would be economical, but do a better job. Somebody figured out something interesting, probably while working at a place that was painting bike frames or some other parts with powder paint, and came up with an interesting idea. He found out that stirring around 2 or 3 layers of Black Crossman airsoft pellet BBs in it, in a number 5 recyclable rated plastic container, there's lots of them, you just look for the recycle number on the bottom, had the effect of generating static charges. This would cause an even coating on any metal object you'd put in that you threw in with powder coating you can get from Lowe's or wherever. Then you can fish it out, put it in a toaster oven, bake it for 20 minutes at 400 degrees Fahrenheit, and then you have a full polymer jacketed projectile. It's a very thin layer, it's intermittent covering, won't be perfect, and you can make it in all sorts of Barbie vomit colors. So anyway, it may not leave any lead or copper barrel deposits or gum on anything, including the reloading dies and resizing dies. You can do it before and after. You may end up with no lead anywhere. You may end up with no poisoning potential. You may end up with a storage life that's longer. You may end up with it being kind of insulated so it doesn't do a galvanomic response with the outside of the shell, causing it to quasi-electroplate itself with rust or, well, lead dendrites. This allows also for you to drive it at the same pressure level, in some cases, as factory ammunition with your loading of how many grains of propellant you want, and maybe only require the same labor as tumble lubricating of a bullet. Now I'm going to cover a couple of things. Barrel slugging. Mostly because I want to annoy the people up here. This will be a piece of information I just found. I was looking up how to slug your barrel. I didn't know what the heck it was, so I'm passing it on to you. It refers to tapping a lead ball or some other soft material through, making sure it's slightly larger than the barrel you're pushing it through the barrel diameter down the bore from either end, I'm assuming. Obviously, you prod it from the large end to the small. Insert joke here, and that's also a joke. This would make you have a mirror image of the barrel's condition, casting into the lead ball measurements for the high and low spots, the grooves and lands, that will tell you the true diameter and true condition of the barrel as far as what would come out of the barrel, and help you determine what diameter projectile you could customize for it for wildcatting, and as well as finding out if your gun needs to be just bored back out and re-rifled or have a liner put in. Barrel liners are available, almost any caliber, usually for the ones that people want to just recycle, and you can put them in using not silver soldering methods. And some of them are tapered, so you can just put them in and they jam fit. You can also look up tinning flux, which is basically liquid solder flux mix that when you heat it up, it tins the surface, but only a little bit. And that can be hardened type material. It can be stuff that will react nicely under explosive pressures. It could also be the silver solder type, apparently can be used, although that's not suggested for this. Next, from mouse to moose loads. Moose knuckle. Some people just like candy-colored projectiles. That's my favorite joke I've seen today about this idea. Now, this also allows you to color code the weights of the projectiles. You could color code the casing for the measurement of how much propellant you're going to put into it. You'll know by look of it what it is. And yes, there is a potential for printing on the bullet and on the casing what the mix ratio is of how much weight of the bullet is, or what kind it is, or whether it's cord or not. Just like they color code lots of bullets. And it does have an interesting allure to it, because you could sustainably do your own DIY materials for this, including looking up DIY powder coating. Now, now you know why a lot of people like shotgun reloads. They're very amenable to it. They can be reloaded many times, and you can just get brass-cased shotgun shells, and they're reserviceable. And also, shotgun shells originally were paper. The metal casing on them was used only if you had to do so to make sure you had a perfect seal. You could get away with using a loose fitting barrel to the action, or have shotguns that relied on that extra spacing to be taken care of by something other than the frame. And also, it made it to where you could have a standardization to it. Paper casings weren't necessarily standardized. You can also look up 40 gram, aka 1.4 ounce, powdered copper or steel wax slugs that are not swaged, but sintered. You mix a tiny amount of some high temperature melting material, plastic or whatever, and use ground up copper or ground up steel to make slugs for shotguns. You can also use them to make projectiles, but you'd have to case them. Now, why is this brought up? That's the weight and rating for something that's used to breach a door. Why is that brought up? Can you make a 410 shotgun fire 1.4 ounce of propelled object? How much propellant would you need? Or how long would you have to make your 410 shotgun shell? And would it look more like a spaghetti stick? The reason I'm bringing that up is apparently one was available, not very popular, because it had one hell of a kick. I'm going to do a video on surface area or bore diameter versus speed versus impact rating versus why do we make cannons instead of making a gun that just fires a dart, and why don't we use round balls? That'll be another video. And again, I'm mostly doing this because I have questions. I learn the answers. It's wrong not to share the information when I find it, and I couldn't find a video that talked about the difference between factory bullets, DIY bullets, electroplating. I didn't bring it up, but it's essentially what you think it is. You electroplate a bullet, or you can just literally shake it around in a Tupperware container with some red paint, powder paint, and then put it in a toaster oven for 20 minutes at 400 degrees Fahrenheit and be done with it. This is why it's rather popular. It gives similar results to factory ammunition. Now, here's the funny part. Some factories are producing powder-coated bullets that you can put into reloads, or just plain old making the bullets this way in the first place. Next, besides lead, you can use zinc. You can use solder. There are bullets that are made out of solder, including lead solder, but also tin, silver, copper, molybdenum, whatever. Bullets. Also, the sintering idea, you can high pressure sinter something by impact and make a reasonably good bullet that breaks apart on impact, turns into dust, so that it can't go any further. This makes a messy wound if you hit something. It may not even kill it, but it will make it not want to come after you. And you can also look up ones that are just made out of powdered plastic that's been rammed together to make non-lethal bullets, or attempt at it, to stop bad guys. That's about it for the day. Thanks for watching. Have a good day. Good luck with that.